So our final video here can be summed up in this table from your textbook, table 21-4. So along the top here, we have different atomic analysis methods. The first three are the ones that we've talked about in this class. And as I mentioned, we didn't talk about fluorescence very much because it's specialized to, you need a laser that works for the specific atom you're trying to look at. It can give you additional sensitivity compared to some of these techniques. So we have flame absorption, furnace absorption, plasma emission, and then the last column is one that we haven't talked about and won't talk about in this class, but using inductively coupled plasma and then doing mass spectrometry and analyzing the atoms that way. That has a significantly lower detection limit, but is significantly more expensive. And we haven't talked about it, we won't talk about it. So in general with these, we'll start with the bottom actually, the purchase cost. Which of these is the cheapest? Flame absorption is the cheapest to both purchase and to run because of the fuel acetylene as well as the oxidant air are very cheap. Acetylene is commonly used for welding and so very easy to purchase and run. Whereas furnace absorption costs a little bit more, so about double the cost of flame absorption. Whereas if you're looking at an ICP instrument with plasma emission, that's 4 to 9 times more expensive depending on the details. So that's often one of the biggest points of comparison when you're looking at these techniques is if it does what you need it to do for cheaper, then you should use that. But if you need the better capabilities, you should pay more money. And in general, you can see as you get more expensive, the technique generally will do better, right? These figures of merit will be better. So coming back up to the very top, we can look at the detection limits, nanograms per gram. This is parts per billion. Flame absorption, it depends which element you're looking at, but these sort of range from 10 part per billion up to sort of part per million level detection limits, whereas furnace absorption can get lower than that by quite a bit, and plasma emission is sort of in that same range as the furnace absorption, maybe a little bit higher detection limit. Linear range is only about 2 orders of magnitude for the absorption measurements, whereas the emission has about 5 orders of magnitude linear range, which is the different levels of concentrations that you can measure. Precision is pretty similar across all of these. The furnace absorption is the least precise. The long-term precision is about the same for all of them. And then we can look at the interferences. For spectral interferences, the absorption measurements have very few, whereas emission, you have to worry more about multiple things emitting in your sample. So there's more issues with spectral interference. With chemical interference, on the other hand, flame absorption, you have a lot of chemical, the atomization process, because the temperature is lower. Furnace absorption, there's a lot more. And with plasma emission, you have very few chemical interferences because of the high temperature of the plasma that you're using. And if we look at sample throughput, that gives you an idea of how many things you can measure in a given amount of time. For flame absorption, it takes about 10 to 15 seconds per element to do an analysis. For furnace absorption, it takes a few minutes per element. And plasma emission, you're instead measuring elements per minute. So plasma emission can go in a much faster. And then, can you do dissolved solids? What sort of range? And then the final one, sample volume. Flame absorption takes the most because you have to constantly feed the flame. Furnace absorption is the least because your sample is contained in that furnace and doesn't leave, and so you can do your measurement with a much smaller amount. Plasma emission is somewhere in the middle. You still need to feed the plasma, but not as much as the flame. And so that gives you an idea of sort of the advantages, disadvantages, why you might choose one of these over another, particularly cost, right? Cost is not something you can ignore when you're thinking about these analysis methods. So that concludes chapter 21 about atomic spectroscopy, and that concludes our last video of the class. You made it. And I hope that you've enjoyed this semester.